Welcome, video example 5, Unit 3, Chemistry 1B. Okay, here we have quite a complex example where we are going to determine hydrogen ion concentration from a specific cell that is constructed with a copper electrode and a hydrogen electrode in their respective solutions. Okay, it says a value of 0.49 volts is recorded for the E cell at 298 Kelvin. What is the pH of the hydrogen half cell? Okay, please note this is not the E cell standard. Okay, so the first thing that we need to do is to write the balanced redox equation and determine the E cell standard. Okay, the standard reduction potential. So roughly the reaction is this one where we have hydrogen going to hydrogen ions and then copper ions going to copper solid. Okay, if we look up these values, the E for hydrogen is equal to 0. Remember, it's the standard value, and the E for the copper is 0.34 volts. You need to look that up, okay, in your standard reduction tables. All right, so we can calculate the E cell standard values from this method here. Okay, then the second step would be to determine the form of the Nernst equation for this reaction. Okay, so we know that if we look carefully, we have two electrons that are transferred. Okay, we've got copper 2 plus going to copper, so there's two electrons transferred. And if we write the Nernst equation for the equation that we were given, we see that the copper solid is not relevant. Only the hydrogen ion concentration is relevant, the copper ion concentration is relevant, and the partial pressure of the hydrogen is relevant. Okay, we were given some information in that regard in terms of the concentrations. Okay, so we can then put in what we know. We know the E cell is given at 0.49. The E cell standard is 0.34. We know R, we know T, we know F, and we know that N equals 2. And we know the concentrations for the copper, and the partial pressure of hydrogen is 1 atmosphere. Okay, so we plug everything in, and now we can solve for H plus, since we have the values, as I've said, for all the other terms. So we have this, we have this, we have for all of these, except for this one, which is the one we're trying to determine. Okay, so now we plug in the values and we solve for the H plus concentration. Okay, and we can see that as we do that, it's quite a lengthy process, but if you work through the steps, it does it step by step, and eventually we get the hydrogen ion concentration as this concentration over here. And then, of course, to calculate the pH, we know that pH is given by this equation. pH is equal to negative log of H plus. And if we plug in this value into the H plus and take the negative log, we end up with the pH of 3.19.